Welcome back, guys. In the last video, we saw the working of p-n junction diode in forward biased and reverse biased condition. Today, we'll have a look at the IV characteristics of a diode. First of all, what is this IV characteristic? Okay, so it's just a plot of current flowing through the diode against the voltage V applied across the diode. And if we are to plot this curve, it will look like this. In the forward bias region, we see that when the voltage is small, the current is almost zero. This continues until the voltage across the diode crosses a certain definitive value, V0, known as knee voltage or offset voltage or threshold voltage. And above this voltage, the current increases rapidly, and for silicon, threshold voltage is equals to 0.7 volt, and for germanium, it's equal to 0.3 volts. We can clearly see that the curve is non-linear, meaning that Ohm's law does not hold good for a p-n junction diode. And for the reverse biased condition, there is a very small current due to minority carriers which flows in the opposite direction, therefore known as reverse current, denoted by Is. And when the reverse voltage is increased, the reverse current remains almost constant till a characteristic voltage called the breakdown voltage is reached. Since this current attains maximum or saturation value immediately, it is called reverse saturation current, and it is independent of the reverse voltage applied and depends on the temperature of the junction diode. It is found that the current approximately doubles for each 10 degrees Celsius rise in temperature. We can see here, when the reverse voltage attains breakdown voltage, there is a sharp increase in the reverse current. The question now is, why all of a sudden current increases rapidly? As the reverse voltage increases, the minority carriers move with greater speed, and some of them collide with the atoms of the crystal. Now, due to this collision, the valence electrons are knocked out from the atoms. Thus, more and more free electrons are produced. This is known as avalanche effect, and with the increase in the number of carriers, the current increases almost vertically, as we can see here in the characteristic curve. We do not operate normal diodes in the breakdown region. We have a special purpose diode known as Zener diode that is operated in this breakdown region, which we'll discuss in the coming classes. So that's it for today, guys. See you in the next lecture.